Hey everybody, see, that was awesome, man. It was a basic introduction. And as I said, here we are in comparing wireless and wired networks. And basically what I'm going to leave you with in the lecture is that, wired, you really need help. You just can't do it by yourself. There's a lot of things that are involved in wireless, a lot of tools that are involved in in wired networks, with configurations and so forth. Running cables, tools where you're running cables. All right, we got cables you got to be running, you got to be terminating them on each end, you got to tone them, you got to test them, you got to do all these different things. So there's something you can't do by yourself, and I'll explain it when I'm in there. But wireless, it should be easier, should be easier. Now, all right, one of the things I talk about in there is called radio site survey, physical site survey. All right, because one of the things with wireless that we need to be concerned with is in any network is interference, and security. We're not going to get into it, but I'm just comparing both, and the little gotchas here and there for both. But in actuality, there's wireless. There shouldn't be a reason why we shouldn't have a wireless network within our company. I mean, we have the speed in wireless, right? You're running 802.11 AC. When we get into the standards, you'll understand that. We got AC, which runs at a gigabit, right? Or close to a gigabit. Now we have the new Wi-Fi 6, that's AX, right? That's running at 10 gigabits per second, right? So supposedly, all right, I guess if we set it up correctly, it will do that, all right? So I'm just going to give you a comparison of between a wired and wireless networks, all right? I'll see you inside. Welcome back, everybody. Now, I know I said I was going to talk about topologies next, but again, that was just really an introduction to what you can expect to the course. There'll be a lot more things that'll be like, hey, that wasn't in the introduction. All right, so yes. So this is something that I believe that you should know. It's like, well, why should we create a wireless network, right? Wired works just fine. Why should we actually, do wireless networks when we have our wired network and everything's working perfectly? Well, I mean, you can think about it in two ways. You can think about creating a wired network in your home or a wireless network in your home or a wired network in your business or a wireless. Now, you're always going to have a combination. As far as your business is concerned, you're always going to have a combination of wired and wireless in your business, whether it be because you cannot reach a certain point in the physical building in your area where you can run wires to and it must be wireless. It could be that within a shopping center, that's where your business exists, and you want to go across the parking lot. Well, you're not going to dig up the parking lot and decide to run a cable underneath or, run like a friggin' a clothesline, across the parking lot from the roof of the building to the other roof. You're going to do things wirelessly. You're going to use, microwave or some sort of that type of wireless technology in order to get across. Okay, like DirecTV, let's say, to make an analogy, you will do that. Okay, so there's different things to take into consideration when you are going to configure a network, what would be good. So let's do a comparison. All right. So in a review of wired networks, when we're looking at that, okay, well, in order to connect different nodes, you need the following. Well, what kind of cabling are you going to use in a wired network? Are you going to still today use Cat 5E or Big E? And that's the biggest controversy of all. 5 little e and 5 big E. Well, 5 little e still goes at a gigabit last. Yeah, if it's for the first 200 feet, it's not really gigabit, okay? You want to run Cat 6 minimum, okay, today, because you want to be able, Cat 5 big E runs gigabit in the first 200 feet or 250 feet. If you're going to run gigabit, if you want to run gigabit, you need Cat 6 cable or better, okay? Because it's going to have the extra twist in the copper, all right? It's going to have the that spleen or spline, whatever the hell they call it, okay? The little plastic thing in the middle of the cable that separates the twisted pairs, okay, of those copper wires. to prevent crosstalk. All right, so you need to decide what type of cable, and you're going to run, and these are cables that are running from your nodes, your end devices, your printers, your workstations, your servers, and going back into your telecommunications closet and being plugged in. All right, so, but you need to know what type of cabling, because that cabling is going to suggest. So let's say you buy Cat 6. That's not cheap. Okay, that's expensive. Okay, or if you buy Cat 7, and you want to go, you really want to be a badass. Okay, that's going to cost you money. And then your end devices, your computers, your printers, whatever, they don't have the capability to run at that speed. Well, then you're shooting yourself in the foot. It's not going to work. Okay, it's not going to happen, and you can't do that. All right, so you got to make sure that everything is going to be compatible with each other, because once you run the cable, you don't want to rerun it again. One of the old school rules they don't mention anymore, that if you are running cables, when you're doing those drops, you will do at least 2 cable drops per end device. All right, so when if you have PVC pipes or whatever the case, you're running those cables through the wall, you want to do 2 drops in there for that one workstation. Why? Redundancy. If one cable goes bad, what? Now you got to run another cable? They're going to wait for you to come in after hours. You're not going to do it during the middle of the day and run a new cable so that computer can work? No. You can have a wireless network backup, all right, where they can connect wirelessly. But then, it's just going to, it may be in the wrong part of the network where you didn't do your site survey properly, and then you may not be getting a good signal. Okay, so this is definitely one of the first things you need to think of. What type of cabling am I going to run here? That's going to make a huge difference. As far as devices, we don't use hubs anymore. I put it there just to warn you. Don't use hubs. Let me get my little laser pointer out here. Okay, we don't use hubs anymore. Okay, hubs, what is it? Okay, what is it? One collision domain, one broadcast domain is a shared bandwidth, right? Shared collision domain, where you share the bandwidth. The more hubs you have, the more collisions you're going to have, the more your bandwidth is going to slow down. Eventually, because it is an Ethernet network, 802.3 standard, you have the CCNA CD, so you're going to run into a lot of issues. So we use bridges or switches. Okay, this obviously would be for wireless networks. You don't have no antennas in a wired network. This would be for wireless. So what to do? Ignore this. Let me get this. This would be for wireless. Okay, not wireless. This would be for wireless, not wired. Okay, so definitely that's something that we're not going to use here. But we can use bridges, switches. Bridges, again, not used. All right, wired bridges, not used, because they're running software. Their main purpose, their main function is for segmentation. It's slow and is limited on the amount of ports. I'm talking about 6 ports. If you see a bridge, anything above that is very amazing. So what you want to look at is switches. So you decide which switch. Am I going to use a layer 2 switch? Am I going to use a layer 3 switch? Then the series of switches. What is it? Because you want a switch that's going to have a good iOS in there, because switches bring in not only where each port is its own collision domain, and it's not shared, is a private collision domain, so you'll have that full bandwidth, that full duplex going back and forth where you can send and receive at the same time, versus a hub where you can only send or receive. Here you can send and receive at the same time, but you have the possibility of creating, or the capability of creating VLANs, all right, and security, and all sorts of different things. Because if you get a layer 3 switch, you have routing, and with switches really brings in a lot of functionality to your network, all right. And then obviously we have routers. Now eventually you're going to end up in a router anyway, whether it be wireless or wired. You end up in a router because it's got to do the translation, because in there we'll have NAT, all right, network address translation, where it's going to go from a private address to a public address and take you out to the internet, right? That's the goal, to go out to the internet. If you're networking within your company, you can use a layer 3 switch without an issue, or you can use a router to do inter-VLAN connectivity within your own private network. That's fine. It's up to you how you want to do it. But again, you need, look what it says right there. Way too much work, and you need at least 2 people. You can do it yourself if you want to, and you can be going up and down ladders all day, throwing that cable through the ceiling, punching it down on the patch panel. All right, and I hope you know what a patch panel is. Okay, punching it down to the patch panel, or just plug it in, because they have patch panels now. They're just RJ45s. So that means you're gonna be, you have the wall jacks that you need to consider. You need the length. All right, you need to make sure, because you have the 100-meter limitation. All right, and which switch is it going to connect to, and all these different things that come into play. So physically, it's much harder to do a wired network. And you do need tools, all right, crimpers, cable strippers, punch down tools, toners, cable testers, all that stuff. And don't be cheesy on it, okay? If you are going to do wired networks, if this is what your life is going to be, where you're going to be running cabling, better buy good, if you're going to cut cables, okay? Because here is just cable strippers. That's why I get the nice ones where you can just spin around, and it gives you a nice even cut, and you won't cut the copper wire. And then when you're going to cut your cables, get a good pair of wire cutters that can cut the 3 or 4 cables at a time, not one at a time. Get good crimpers. So buy decent tools. Don't skim on the tools. Don't be cheap on it. Don't be frugal, to say it nicely, on the words, because if you do, you're going to pay the price. Especially when it comes to toners and cable testers. Buy good ones, because definitely you're going to have to tone your cables. Just think about it. It's not only getting the rack together, putting all the equipment on the rack, and then you're running your cables from the end devices to the rack, separating. More likely you'll be separating voice and data, and then when you're punching these things in a punch down tool, don't get a cheap punch down tool, because you're going to get pretty pumped up by the end of the day. Okay, and if you have to tone. If you're going to do things correctly, if you're going to be a network engineer, and you're going to, or an IT individual, you need to do things correctly. Okay, unless you're going to outsource this stuff. Okay, and if you're the person that's being outsourced, do it right. So you got to label this. Okay, this particular run is going to this end device, which is in this department. Okay, and it's in this port. So you need to write all these things down. You have to have documentation of it. And then after you tone it, you have connectivity. There's no broken pieces. You have full continuity. Then you punch everything down in the patch panel, and you create, and you punch it down in the wall jack, and you do your patch cable that's going to it. Well, you can test right there. But if you want to just do your patch cable from the wall jack and test that cable to your PC, however you want to test it, okay, you want to make sure that the color coordination, the standards, right, which we'll talk about standards, which is pretty much the EIA, TIA, 5CC, A, and B, okay, either one, whichever you're going to use, okay, you need to make sure that you get what's called a full house. All lights light up, you get green. And obviously, once you do terminate, then that's what it's called, terminate on either end. You make sure that when you plug in the computer, that you can ping. All the computers already terminated, everything is plugged in. You can then test it by pinging and see if you can actually get that done. But that you have to label it. So you're talking about not only those tools you see there, but you got to get wall plates. Okay, you got to make sure you get the wall jacks, the RJ45 plugs. You got to get all these different things, and you need to, that hopefully the rack will already be there with the patch panel and the switches and what have you. But these are all things, as a network engineer, as an IT professional, then when you're going to go set up a network, and I'd say from scratch, okay, you're going to need all these stuff. If you're walking into a network, it's an existing network, you still want to review all these things. You want to analyze all these things. It's sort of like a risk analysis, if you would. All right, but you want to walk around. You want to take a look at what they have. if the wires, because they're having issues with it. Then I said, listen, if you just, lift your wires, fix this, punch it, make it up. Some people punch their cables and they have all these copper wires just, creating all this interference because they're all bare and you can see them and they're just touching other high voltage, because low voltage, which is, network cables versus high voltage, AC cables. All right, you need to be separated. They can't be close to each other because you're going to create interference. So imagine. And here you can run a gigabit, right? Gigabit per second, depending what you're running. Internally, you're not going to run anything more than a gig. That will be just a little bit of an overkill. If you have the money, then hey, knock yourself out. But at least a gig. Should be at least a gig, 1,000 megabits per second. Okay. And like I said, but if you do have the right type of cable, you could go faster than wireless. And again, today's wireless, okay, with the 802.11ax, it's really, they promised 10 gigabit per second. I want to see that happen. Okay. AC is pretty much the one you're going to get tested on all the way up to, because we have 802.11a, B, G, and AC. AC is the highest one. These are the different standards, which we'll get into that. We'll talk about all the different standards, but at least AC, because AC will give you the gig or close to it anyway, very close to it, if you do it correctly. If you do your radio site survey as well, okay, and make sure that when you're placing your APs and all that stuff, and we'll look at the devices at the end of this particular lecture that you're going there for wireless networks that you have. But you can see that with a wired network, it's a lot of work. It's a lot of work because running the cable is not easy. All right, I can tell you that right now. Okay, punching everything down. You'll have your biceps and your forearms will be pumped up. You don't need to go to the gym. You get to go work out there. Okay, and it's going to take two people. It's going to take two people. So salary-wise and all that, I mean, it's nice. You need to eventually, have wired. It would be nice to have a full wireless network, but your security better be in check. So if you look at a visual, a very, very basic wired, right? You got two computers right there connected to a layer 2 switch that's connected to a router, and then that router is connected to your ISP. You know what I mean? Whatever protocols you're using right now, you don't care, but this is how it will look, right? And this is a very basic drawing because really you're not plugging in straight to the switch. Okay, this is something we do for practice, whatever. You will have an actual telecommunications closet where the runs will be from wherever this PC is at, okay, to the telecommunications closet, to the patch panel, and from the patch panel, it goes to the switch for that particular department, and that's the way it's going to be. And then from whatever core switch that this is going to be connected, this switch, right, which would be, let's say, an access switch, to a distribution switch, and then to your core router, or it could be a core switch, all right, a very high-end switch like a 9000 series switch, and then go out to the internet. It all depends on you. It all depends on the network. So that's why it's just, you can't just walk into a place and say, oh yeah, okay, what do you want? Yeah, I'll get this done. Hey, unload the equipment there, Joe. Yeah, just dump everything out. Let's just start unplugging stuff and just plugging things in. It doesn't work that way. Don't do that. You have to go into a business or even your own home. You need to make sure, okay, what will be the best way? I can tell you right now, my shoulders hurt, my knees hurt, my elbows hurt. I'm not running cable, okay? If I have to do it to a business, I will outsource it big time, unless it's something very simple, all right? But in my home, everything is wireless. In my home, the only wire is the one going to the wall from the router to the wall, all right, to take me outside. That's it. What my ISP came and plugged in. That is it. Everything else in my house is wireless, all right, 802.11 AC, the standard, gigabit, okay? And I use that standard because I do have a gigabit up and a gigabit down. So it's not a bottleneck that I have, because imagine I'm going 1,000,000 miles an hour, all right, or 1,000 miles an hour internally, like when we share files, between one computer and the other. People can watch TV, internet TV, right? The wireless TV. And then you have the cell phones. People can be on their cell phones, wireless, not using their data, but they're wireless. Okay, so they connect to the router as well. All right, so I have all these different devices, but it can handle it. All right, and then all this traffic, I could be running a boot camp. I could be doing anything online, looking at videos online or whatever the case may be. And I can still have that pipe. All right, so I'm running gigabit internally, which hauls ass. I can print fast. I can do everything fast because it's internally. And then if I have to go out to the internet, it's still going to be fast because I still have that gig. So I don't have a bottleneck. When we get into the standards, we'll discuss something important because with wireless, and we'll get into wireless right now, with wireless, we run into interference. And when we get to that chapter, but just to give you like a little sneak peek into it, now that is a very, this is what they would consider a basic service set. Let me see if let me try and write that. That should be interesting. I'm just going to put the abbreviation. This S. Okay. If this would be a basic service set, which in actuality would not be a router. Amen. Okay. It would not be a router. It would be an access point. And that's one of the things you need to understand. All right. In a home, normally, what you have is whatever, it's an all-in-one, really, for 95% of the population. It's a wireless router that you get from your ISP, which has wireless already. It has the capability, depending on your ISP, that it understands the difference between 2.4 gigahertz, that's one frequency, right? 5 gigahertz. I always tell people, run at 5 gigahertz. That's the way you want to do it. And then when we get, like I said, when we get into that chapter, we're going to have a nice little discussion with that one. And I'm actually going to put up a question that's in your book. Because with 2.4 gigahertz, all right, if you're running, let's say 802.11, which is the wireless standard, 802.11, all right, the IEEE standard, if you're running, even if it's N or AC, you have, because with G, all these B, G, they all, B, G, N, AC, they all can run at 2.4 and 5 gigahertz, right? If you run at 5 gigahertz, you're going to have less interference. You're going to have less interference than you will with 2.4. Because with 2.4, every appliance, let's say, all your entertainment appliances, okay? If it's a even a radio, TV, or your microwave, it's like, where do you want the modem? Your ISP comes and says, where do you want to set up the modem? Or you're putting the all-in-one router / access point / modem, whatever, all-in-one. You're gonna say, where are you gonna set up this device? Where are you gonna put it? Where do you want it? Well, I want it there next to the TV so I can have everything together. Well, that's not too bright, okay? Because this is a device that has omnidirectional antennas, and they're all, it's being interfered with the EMI from the TV, all right? Not just the magnetic interference, right? There's so many things that interferes with that. That's even funny. No, you want your router separate from any other electrical devices. If you ever to walk into a Best Buy, all right, you'll see that if you look up, and they may have changed, okay, but normally I've seen them. They have access points in the front of the store. They're pretty far apart from each other because there's nothing really in the front that interferes with them. There's, all you have is the registers, and you have the cell phones there, but you really don't have anything that's emitting a lot of EMI, okay, or radio interference, RFI, okay. But if you go in the back of the store where the TVs and all these different things, all these electrical devices are at, and they're running constantly, you see the access points are closer, okay? Because they need to be able to communicate with each other because there's a certain distance. And again, I don't want to talk about it now, but we'll talk about it later on. when we get into the standards, okay, and how an actual, wave length and frequencies and all that stuff. All right. The less, because 2.4 gigahertz is less frequent. That makes sense, right? It's a frequency, and it's less frequent than 5 gigahertz. It's more frequent, but then the amplitude of that wave, right, is smaller, so it can travel a smaller distance. But with 2.4 gigahertz, you only have 3 non-overlapping channels, which are 1, 6, and 11. And with 5 gigahertz, you have 23, I think, 23 or 22, if I remember correctly. And you'll know for sure when I get to that section. Non-overlapping channels. So they don't overlap, and that's due to many things, all right? But then you also need to think about, when you're creating a wireless network, you need to think about, well, what equipment am I going to be using, right? Because that right there, it says here, easy to set up. You have no cables. There's no cables. It says there are fewer configurations, but really, is it really fewer configuration? Not really. Not really. I'm gonna put a question mark right there. Okay, not really. It's really, there's a lot of things that you need to do, because it all depends on what type of wireless network you're doing. Are you doing? You are, at least when we get into the topologies and we're looking at an actual floor, I have an actual visual image of a network. Okay, how many APs am I going to need? Am I just using APs and then they connect to the router wirelessly as well? Do we have APs that connect wirelessly or wired to a wireless controller, and then the wireless controller goes connected to the router? So how is it that we're configuring, and what type of security, okay, are you going to use? So as far as fewer configurations, yeah, when wireless first came onto the scene, it was pretty easy to do it. I mean, you can do it yourself. Just slap on the wireless PCI card or the fob or whatever it is. It looks like a USB. Just plug it into a USB port. There you go. There's your wireless antenna right there. And then you got a wireless router. Boom. There you go. You got wireless. Okay. But then as we moved on in the wireless technology, you see that we have, now we have gigabit speed. We have multiple in, multiple out, the router with a lot of antennas. Like I used at one point the Google router, I think it's called Uno, which has 10 wireless antennas. It supposedly gives you a coverage of 10,000 square feet. All right. I mean, I never had any issues with it. All right. And it does bring software. It does bring software with it, and it gives you actual images. It's like a little dashboard that you're using. It's like an APIC, guys and gals. All right, where you log in, and then you have this little dashboard, and you can take a look at your network, who's on it, is there something wrong? You can control it like I would control, my kids were, hey, they would tell me, hey, the wireless is down. Really? Oh, must be your phone. No, it was me turning off their wireless connection to their phone. So it gives you all these features, okay? So it gave you all these features where normally home routers will give you certain features. It all depends on which type of router you want to get. But there's other routers that have a lot of features that are available to you, especially the power output, okay? This is something that we'll get into a little bit later on, because you need to be able to control. And really in a business, if you buy a business grade router, is where you're going to see those features that they have. It's available to you. All right, the RRM, the TPC, all these different things that you can control, how people connect and how frequent they pull the APs or the routers, okay? And you want to be able to control how far out you want that signal to go. Because based on the power that you put through that particular wireless device that's emitting everything out through the antenna, whether it be omnidirectional, directional, okay, especially in a home, you don't want it to leave your house, or you don't want it to leave your yard, let's say. But if you live, pretty close, to your neighbors, they can get your network. They can, because by default, all these routers that they sell you in these stores, you have the, default passwords, default SSIDs, DHCP is enabled by default with default IP addresses. So if you just leave it like that, and you just plug in your equipment, yeah, you're online, man, you're surfing, you're having the time of your life, but so is your neighbor, okay, on your network, okay, on your internet. They don't even need it. They just use your wireless network. And that's it. So you got to be very careful. You got to do a lot of things, and we'll see when we start configuring this stuff. You're going to see that you need to be very careful when you configure. But yeah, it was easy. It was easy. It was just basically, hey, make sure all your end devices or whatever, if it's a printer or if it's a PC or whatever it is connected to the right, what's called your, because BSS is a basic server set that you just saw, which is just one device connected, all your end devices are connected to with this one device, right? So that would be a basic server set. And again, this is something you need to think of. It's like those hubs and switches, okay? Do you want a basic server set? What is it that you're doing on your network? Because if you're just playing bingo online, okay. But what if you're gaming? What if you're gaming? What if you're creating a LAN party? And you just, I don't want to wire stuff up, man. Let's just do it wirelessly. You know what I'm saying? And yeah, that's going to kill. Yeah, you're going to freeze and they're going to snipe you. Okay. So that's not going to happen. So if you're doing something like gaming, or you're doing designing, web design, or, massive databases, or whatever the case may be, yeah, that AX is maybe that's what you need. Okay. That new Wi-Fi 6. Because you need those 10 gigabits per second. But so think about what is it you're doing on your network when you're doing wireless, all right? And the security, that's the biggest. This right here is one of the biggest issues. Not only speed, because everything interferes with wireless, a leaf, air, your body, everything interferes with wireless, regardless. But again, depends on the amplitude of the wave, and the power that's being emitted is going to create the actual frequency. But you guys say, okay, because things that you will be calculating will be decibels, gain and loss, to get the effective isotropic radiated power, which is the actual force that's coming out of your antenna. You got to make sure that it's powerful enough to get where it needs to go. But we'll talk about all that stuff when we get to the math portion. It's not that big of a deal. But you need to understand this, because when you do create topologies and you have more than one router in a business, you have more than one AP, I should say, more than one AP, you need to make sure that there's I believe the magic number is 50% overlap that you can have so you can roam. And roaming is where you're being handed off, just like when that's when you're driving in the highway. It's the same thing. But that's cellular technology. It's still wireless, cellular, right? When you're driving down the highway and you're coming home from work and you're talking to your spouse, and they tell you, hey, remember to bring home hello. What happened? Dead zone. Because the tower, there wasn't another one nearby that it can hand you off to, and it can pick you, the call can continue. Okay. And when it first began, that was a huge issue. But now, there's plenty of cell towers that are around with the antennas for specific companies all over those cell towers. The radio towers that you see is just really those steel towers that you see. They go all the way to the sky and have a little red beam so planes don't crash into it, a little red light on top. Okay, but it's the antennas that you see around it. All right, that is what's giving you the possibilities, and those antennas, and we'll talk about it. All right, because in this new test they talk about 3G, which I think is hilarious. Okay, but either way, you have those antennas which are based on vectors. Okay, and each vector cross-sects each other, so you can, wherever you're at, you always have signal. Well, there used to be 3 vectors, now there's 6 vectors, so you have 6 antennas, and then those antennas are connected to a particular cable, coaxial cable, more likely, or fiber, and it's coming down because underneath those steel Eiffel towers that you have there, all right, it's going into there's like a little house at the bottom. That's how I describe it, like a little house. And inside that little house, that's where all the devices, the DHCP servers, the routers, everything that you need, what we called in Metro called SIUs, that actually send things to the switch to give us, the information so we can send it back and send you wherever you need to go. Because remember, if you're talking from, let's say, AT&T to Verizon, those are 2 different companies. So every switch has to have a connection back to every other provider in order for them to get you there. But that's another story. Whole point is that for a wireless LAN, okay, yeah, it used to be easy. It's still kind of easy, but the configurations, there's a lot more configurations to be done. And definitely security is one of them. And you do want to have, where you see their controllers, which are wireless controllers, because those wireless controllers, in a big network anyway, are the ones that are going to send all the information to the access points, which are then going to send that information to you, the user, all right, to be able to control it. So, and the controllers will then be connected to the router, and then all the updates that come into the controllers will be so it goes from routers give them information to get to the internet, what have you. The AP gets updated automatically where whatever updates or changes that need to be made, and then they decide, okay, which APs I'm going to connect to, if this is VLANs or whatever. So it's that's a little bit more complex, but it's easier in the long run. More work up front, all right, as far as configurations and types of topologies, which we'll talk about later on in the course, in the section, in the sections to come. Definitely controllers is, if you're working a network, that will be the way to go. Bridges are used in wireless networks. There's bridges and repeaters. Because wireless bridges and wireless repeaters are the ones that are going to expand your network. Now there's cheap wireless repeaters, okay? So be very picky on what you use. I've gone through, I don't know how many wireless repeaters. All right, it's just a matter of you doing research, but that's what they do. They extend your network. I myself am using right now, it's from AT&T, because I'm on the 2nd floor. All right, my wireless all-in-one router, it's on the 1st floor, but I have a repeater from the same company, AT&T, on the 2nd floor, so it repeats the signal to me. So it's like I'm, right next to the router. I'm getting very good signal from it. All right, so that's one thing. And bridges, really, if you want to go further than normal, you would use wireless bridges because they're made for distance, okay? So you would use that. And then you do have a wireless wide area network. That does exist. We're just talking about it, which is cellular, right? But you literally could, like it says there, VSAT, which is virtual satellites, okay? Like, let's say DirecTV, all right? Microwave, things of that nature, where you can have, all right? But that takes other types of calculations that you can use, particular types of software and things that it would have. So wireless networks, it is easier. You could do it yourself. You really don't need 2 people. You could do it yourself, but it all depends on the size of the network that you're doing, all right? Because you're doing an enterprise network and you're doing a wireless wide area network, then that's something that at least 2 people should be, okay, hey man, if you're on the roof and they're at the actual PC checking the configurations, checking the strength of the signal to make sure you're at the right azimuth and elevation and all the things that come with a wireless wide area network, because you do need to have that direct connectivity, whether it's to a satellite, because even GPS, I did GPS surveyors. If you ever see them out there, the people, that measure the streets and all that, if you didn't know that, okay, some people don't, you can do GPS surveying where you set up, you do a triangulation between seven military satellites and a proprietary frequency. So you're walking around or driving around with your devices, okay, that connects back to the base station, and it triangulates it based on satellite and radio frequency, which is proprietary to you, to give you an exact. And how exact? We're talking about hundredths, okay, hundredths. You got to be within 500ths of where you're at. Okay, so you think about a corner of a building. And there's checks that you do when you're doing stuff like that, because there's so many different types of wireless technology that exist: Bluetooth, Z-Wave, not just the typical wireless that we're aware of with 802.11. There's a whole bunch of other wireless networks out there. The cellular that we were just talking about, that we'll get into later on. But for a basic wireless LAN, no biggie, but be detail oriented. And definitely one of the things when you are setting up this wireless network, because you want the LAN to be wireless, meaning everybody within that company is connecting to all the different devices, shared folders, and all these different things, printers, that they can connect to it wirelessly. So you don't have to run cable, save your knees and your elbows. Okay, it'll be quicker to set up. All right, but that's why in this last slide here, you have your laptop, obviously. Okay, and then you have, and this is an AP. Okay, and you see you have two different routers here. Here they have a home router, and here they have like a business type router. It's the same thing. Okay, but you see it says AC, which is 1000. They do have an N, and I think they have just a regular home router, but I chose the AC router. Obviously, this is from the packet tracer. Okay. Normally they had this, but now with the newer packet tracer versions, they have the AC, and they have this one. You have your wireless controllers, and you have access points. Okay. If I were just to go, I'm going to switch over to the packet tracer. Hopefully it will be seamlessly. All right. Cool. If I go into this laptop, all right, and I turn off the laptop. Now, hot swappable, people. All right, and I get the wireless card, which is right here. All right, and I turn it on. All right, so that's turned on. Who the hell's it connected? Nobody. Oh, look. Oh, because I have something over here. Why did it connect to that AP? This is the closest AP. Why didn't it connect to this AP? That's hilarious. Okay. That's hilarious. Okay, access point 1, port. Let's see here. Port 0 is on. But these are the actual interfaces that you would connect to. Okay, you see the SSID here is the default. Well, we can change that. Let's change that. Let's change this. Let's call it LAS. All right. Let's call it LAS. And let's go into the actual laptop and go to not go here. Go to where? Here we go. Wireless 0. Okay. And the SSID, which is the security set identifier. And when we get to the labs, this is just to show you LAS, right? So based on what I just put here, this, there you see, now I connected to that. All right, it should have connected to this to begin with, because they're both, I have defaults, okay? But it connected to the one way down there. That was funny as hell. They should have, you can say it's a packet tracer. It'll connect to whoever. But that's why the wireless controllers also come into play. And we'll do a lab with wireless controllers as well. All right. You see I connected to that access point, which then could be, and this would be if you use everybody to connect just to LAS, right? When I bring another one up, I make sure I change it so they have that SSID, security identifier, and they will connect to that particular port. But if this is eventually going to connect to a wired router, okay, what's that topology, or what this is right here, if you have, let's say, let's just use, all right, obviously it's red because I don't have any IPs or anything turned on or anything like that, okay? this would be considered a distribution system, all right? Because you're taking it to a wired network. And eventually that's what it is. Because when wireless first came about, they wanted, sometimes it was just so difficult. And I've done houses where the attic stops halfway through the home and I had to run it down the wall through the carpet, where if it was just wireless, it would have just been a lot easier. So there's certain places and certain buildings and certain homes where there's certain areas that you just can't run wire through. And this is where wireless is. And the access point that where it says it is access to a wired network. So it can be connected to the router, it can be connected to a switch, then to the switch to the router. It all depends on what is it that you're trying to do, and that's the topology that you will create. So as you have your normal, star and all this, there's just all different types of wireless topologies, basic server sets, independent server sets, extended server sets, a full-blown friggin' mesh network that you want to have. That's up to you how you want to do it. But eventually you're going to have to end up somehow into a line, because even though that I'm connected wirelessly to my home router, okay, and then that router is connected to the wall through a wire because I need to go outside to my ISP. All right. Now there are places, that, and they're still connected wired, because I know in Miami Beach, the whole city of Miami Beach is wireless. First time they tried, they failed. This was tons of years ago. But anywhere you go in Miami Beach, you have wireless connectivity, which is awesome. But there's so much that you need to understand about wireless and the wireless wave and the standards and the interference and all that, which we will get into. But just to do a comparison like we just did, okay? A comparison like we just did right here between wireless versus wired, that's the big thing, okay? Because, you're eventually going to get to a wired network, and you're not going to reinvent the wheel. You are going to do your walkthrough a company and say, hey, you have your wired network is fine. Okay, you've toned, you've tested, you've analyzed, what have you. You need to do all these things first. And then if they do want a wireless network, that's their goal, then you have to do, and we'll talk about this later, your radio site survey. So you know where you're going to go ahead and put the access points. So you get the best signal, and you have that 15% overlap because you don't want co-channel interference, okay? So you can be able to hand off as you're walking around, right? Like in the school system, which I worked in, you want the student, he's running late, he wants to print out his homework, he can be in the parking lot, print out his homework to the printer in the classroom he's supposed to be in. That would be cool, right? And you get credit for your homework. So these are things you need to think of. So you can see it's just not willy-nilly. There's design that goes into this. But obviously, yes, in a general sense, wireless is easier, okay? But when it comes to configurations, even wired configurations, if you want to do things correctly, there is a lot of configurations. But definitely for wired, you are going to need two people. Wireless, it depends. You can probably do it yourself. But again, you always want to have somebody maybe in one side making sure that, hey, I got connectivity, I don't have connectivity, this is the SSID we're using, whatever. You always want to use a minimum at least of two people, but you can probably get away with it in wireless. But in wired, you can't. In wired networks, you cannot. All right, because then you'll be running back and forth like a mad person. All right, you don't want that. But very a little bit, a lot of review here. But just remember, wired LANs, wired is 802.3. which falls into the CSMA CD Ethernet standards. Okay, keep that in mind. And then for wireless, all right, it's CSMA CA, which is collision avoidance. And that is 802.11. Now remember, you have different standards, which we'll talk about. You have A, B, G, N, AC, and now we have the new AX. But AX, I'll mention it very, very lightly. Not gonna, because nobody's gonna be using that now. All right, and remember, last thing I promise. Are you running IPv4 or IPv6? And does your provider support it? All right. That's another thing to think about. That's another thing to think about now with IPv6. So a lot of things that you need to take into consideration before you decide if you're, wired, wireless, and which type of wireless I'm going to use and which type of device am I going to use. Okay, if I want to use a combination of all these different devices, because I have to do different things. And very important, segmenting the network. All right, enough said. I hope you see that this is going to be a full-blown wireless thing. This is not going to be just a flyby, hey, this is very easy to do. No, there's a lot of configuration that goes into it. And you really need to understand it, all right? I'll see everybody in the next one.